Hello everyone, welcome back. Today we're going to solve a fun and easy coding problem, which is number 1512 of LeetCode. It's called number of good pairs. We're going to go over a few different solutions, starting from the most basic brute force approach and working our way toward more efficient ones. So let's take a look at the problem description. It's pretty easy. We are given an array of integers nums, and we need to return the number of good pairs. So a good pair means that the values are identical in the list. And I'm going to quickly remind you how indexing works in Python. So let's say this is our list, and indexes start from 0 on the left and they go up. So this value will be index 0, 1, 2, and so on. That means we need to find the good pairs using the indexes. That means the ones have pair index 0 and 3, index 0 and 4, then also 3 and 4. The value 2 does not have a good pair, and the 3s have also one good pair with index 2 and 5. So we can see that this is exactly as the explanation of the problem tells us. So let's just implement this approach using a for loop. It should be pretty easy. To access each starting element, we will use a for loop. For I being each element of the list, for I in range of length of nums. Here, the length of the list is 6. That means we have the range of 6. And then for each of these elements, we need to loop over the rest of the list. So we need another nested for loop. And we will use a different letter. Let's use J. So for J in, what will be our new range? In this case, we don't need to start from the beginning of the list. We need to find the I element and start from the next one. So let's write I plus 1, and then we end with the last element. So that will be the length of the nums. And then we compare these values. Let's look at the description again. We're free to copy and paste it. So let's write the if statement. If nums I is the same as nums j, we need to implement some counter. Let's do it at the beginning. We will initialize at 0. And if this condition has been met, we add 1. In the end, we need to return the count. Let's run this code to see if it works. Yes, all test cases have passed. But as you can see, we are using the nested for loop, and this approach has a pretty high time complexity because it's O of n squared. So we should probably be able to optimize it a bit. So usually, if we are not happy with our n squared time complexity and we would like to improve it and get On, we should consider using a dictionary. So let's see if we can achieve that. So this time around, let's use a dictionary. Let's initialize an empty dictionary. We will use, similarly as before, some form of a counter. We can call it good pairs. And again, as before, let's use a for loop. And for each of these elements, we need to look it up in the dictionary. So let's see, if num is, no, sorry, if num in count dict, if it is in the dictionary, we will have some logic. If it's not in the dictionary, we need to put it there. And we will do it by creating this entry, count dict, where the key will be our number. And we initialize it with a 1. So again, if the number is already in the dictionary, let's say that our theoretical dictionary already has this entry, so the number 1 has appeared one time, what we need to do is that we will update the number of good pairs with the value from that dictionary. So that will be count dict num. And we update the dictionary again. At the end, we return the good pairs. Let's see if it's working. It is, and this solution reduces the time complexity to O of n, and also the space complexity is O of n because of the dictionary. And the next idea that I have for this problem question is actually simplifying the dictionary part, because Python has a collections module that has inbuilt the defaultdict type, which could be pretty useful in this case. So first we would need to import it from collections, import defaultdict. This way, instead of initializing an empty dictionary, we will initialize a default dict object where the values will be integers. This solution is more simple because we don't actually need to check whether the key exists before updating it. And the default dict automatically initializes the count to 0 when we first encounter a number. So that means that it's taking care of this case for us. And also we don't need to check if the key already exists. Therefore, for each num in numbers, we can go ahead and delete the redundant code. Let's run it. Okay, awesome. And then the solution number 4 that I have on my mind is using another container type from the collections module, but this time it will be the one called counter. And at the same time, we could make use of the hint provided to us by LeetCode. After we have counted how many times each number appears, we can use this formula to get the result. So let's first import the counter. So this time we will call this value counts, and it will be the counter object that we get from the nums list. And what the counter does, it will convert this list to an object that is similar to a dictionary, where the key will be the list element and the value will be the number of occurrences. So in practice, it's going to look something like this. Key 1 has 3 occurrences, key 2 has 1 occurrence, and key 3 has 2 occurrences. So having that, we don't actually need to iterate over all of the list elements. We can just iterate over the counter dictionary. And again, let's take a look at our hint and the provided formula. So we need n, and our n will be count dict. No, this is counts. Counts nums multiplied by counts num minus 1 floor division 2. And let's see if the test cases pass. And it also worked. So here the time complexity is again O of n, since the counting of the elements and calculating of the pairs both take linear time. So we've walked through 4 different solutions, starting from a brute force approach to more optimal solutions using dictionaries and counters. You should remember that the brute force approach is good for understanding the problem, but as you can see, using more advanced data structures like counter or defaultdict makes our code cleaner and more efficient. I hope you found it helpful, and see you in the next one.